Okay, so today we're going to be reviewing mostly things from first semester. We're going to start with scientific notation. So first thing we'll talk about is what has to be true in order for a number to be written in scientific notation. A number is written in scientific notation if it's a number times 10 to another number. That first number should be between 1 and 10. The second number has to be a positive or negative whole number. So we'll go ahead and change these numbers into scientific notation below. My decimal for the first one is at the very end at the right. We have to move the decimal until the number is between 1 and 10. So I'm going to move it 1, 2, 3, 4, 5, 6 times till it's between 2 and 5, because that gives me the number 2.54, which is in between 1 and 10. So now I'm going to rewrite it as 2.54, pardon my handwriting, and I moved it 1, 2, 3, 4, 5, 6 times. So it's going to be times 10, since this was a big number to start with, and I moved it to the left. I have to move back to the right at the end, and so this should be a positive 6. Second example here, my decimal right now needs to be moved again. We have to move it until the number is between 1 and 10. So I move it 1, 2, 3. Now it's at 2.76, which is between 1 and 10. So I'm going to write 2.76 times 10. It's going to either be positive 3 or negative 3. I know it needs to be negative 3 because if we wanted to move it back, we'd have to move it to the left. Or you could think that, okay, this started as a small number, and so it has to be a negative 3. Now we're going to move on to properties of exponents. There's a box at the top that says all the rules of exponents. Remember, we can only combine terms, really, if we have the same base. And so if our bases are being multiplied, we add our exponents. If they're being power to a power, then we multiply our exponents. If they're being divided, we subtract. If it's raised, if anything's raised to the 0 power, it's 1. And if I have a negative exponent, remember we talked about like our sibling is being salty and being sassy, and so we have to send them to the other side of the house whenever they're in a bad mood. So this guy, since he's negative, he has to go to the other side of the house. We're going to jump right into these examples. First example, I have 3 times 3 to the 8th. Well, 3 doesn't have an exponent right now, but there's only one of them, so it's 3 to the 1st. Since I have the same base and it's being multiplied, I add my exponents. So this is really 3 to the 1st plus 8, so it's 3 to the 9th. I add my exponents. Next one, I have 6 to the negative 5. Okay, that's my little sister, and she's being salty. She's got to go sit in her room for a little while and take a break. And so she needs to go the other side of the house. This isn't a fraction right now, but we'll make it into one. She needs to go over here and sit in her room for a while. She's going to be sent to the basement. So this is going to become 1 over 6 to the 5th. Whenever my sister goes to her room and calms down, she gets in a better mood and she stops being so negative and salty. Next one, we have 2 to the 6th raised to the 4th power. That's power to a power, and so I multiply my exponents. So it's going to be 2 raised to the 6 times 4, which is really just 6 times 4 is 24, so 2 to the 24th. Next one, we have 6 to the 5th over 6 to the 2nd. That bar in the middle means division, and so I have to subtract my exponents. So this is 6 raised to the 5 minus 2. Well, I know 5 minus 2 is just 3, so let's change that into 6 to the 3rd. Right along here, we have another one that's the same base. They're both 7s, and it's division, so again I subtract. 7 raised to the 4 minus 9. Well, I know 4 minus 9 is negative 5. And so I'm going to change that to negative 5. Okay, but that's like my younger sister and she's being salty. So she's got to go to the other side of the house and take a chill pill. So we're going to send her over here. And so really this one becomes 1 over 7 to the positive 5. Once she goes in the basement, she's happy. I should probably fix it. Next one, I'm going to simplify the top first. So on the top, I add my exponents, so I get 5 to the 9th, and I still have 5 to the 7th on the bottom. Well, I have the same base in division, so I'm going to subtract. 9 minus 7 gives me 5 to the 2nd. Bottom row here. On that first one on the left, we know anything raised to the 0 power is 1. So what's inside this parentheses really just is 1 because it's all raised to the 0 power. So 14 then times 1, put that in parentheses. 14 times 1 is just 14. So for my answer for that one, I get 14. And then this last one, we have power to a power, and so we're going to multiply to both of these exponents. So this becomes 4 to the negative 6 over 5 to the negative 4, but these are both negative right now, so I have to send them both to the other side. So it's 5 to the positive 4 then over 4 to the negative, 4 to the positive 6, sorry. Now we'll talk about rational and irrational numbers. This was the very first unit that we did. On your page, you have some definitions of rational and irrational numbers. Rational numbers can be written as fractions. They are whole numbers, normal numbers, things like integers, decimals that end, that they repeat, they have a pattern. They can be square roots of perfect squares. So anytime you're getting something that seems like it's not crazy, it's probably rational. And then irrational numbers are crazy. They are decimals that go on forever, but they never repeat. So their decimals are going to be random. They should not have a pattern. If I take a square root and I get some crazy decimal, then I should say it's an irrational number. So you have that on your paper. Make sure you look over that and use that to answer questions today. So first up, what's a perfect square? Well, I know that a perfect square is a number whose square root is a whole number. So that would be things like 1, 4, 16, because 1 times 1 is 1. So we're going to list our first 12 perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. This is a good method, by the way. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. And 11 times 11, that's 121. And 12 times 12 is 144. So the square root of 144 is 12, which is a whole number, which is where that definition comes from. Next up, we'll talk about perfect cubes. A perfect cube is a number whose cubed root is an integer. So I'll give you some examples here. So 1 times 1 times 1 is 1. So 1 is a perfect cube. Or the cube root of 1 is 1 because 3 1s multiply together to get a 1. We could do 2 times 2 times 2, which is 8. The cube root of 8 is 2 because 2 3s multiply together to get a 2. Let's see, 3 times 3 times 3 is 27. 4 times 4 times 4 would give me 64. 5 times 5 times 5 would give me 125. So those are 5 perfect cubes. On your calculator, if you want to do a cubed root, which is this thing, then we do that by clicking the math button, and then you'll see it under 4, so we click math, 4, and then you'll have to type in your number and click enter. Now let's apply what we talked about rational and irrational numbers. The first one, 3/11, is rational, and that's because it's a fraction. Fractions are normal. Next, we have the cubed root of 100. What I would do is I would type that into my calculator. When I do that, I get 4.6415, and it goes on and on and on. So this is an irrational number because it is random and it goes on forever. It's not repeating, it's not a pattern, so it's irrational. Next one, we got the square root of 16/9. Okay, I know that the square root of 16 is 4, so on the top here I really just have 4. And on the bottom I have 9, so the square root of 9 is 3, so you end up getting the square root of 4, or you end up getting 4/3 for your answer, which is a fraction, so it has to be rational. However, if you were to type this in your calculator, you would actually get a repeating decimal. And so this is rational because it's a fraction, but if you went ahead and just type this into your calculator, that says fraction, you would get something that's repeating. And remember we said repeating numbers are rational because they have a pattern. Last one here, the square root of 5/2. If I type that in my calculator, I get something like this. 1.11803, and it just keeps going. This is an irrational number. Irrational because it's random and it keeps going forever. The calculator doesn't show the entire thing, but that's because it can't fit it all on the screen. It would take forever. Last thing for today is simplifying expressions. We're going to talk about distribution and combining like terms. Distribution, we multiply what's on the outside of the parentheses to both things that are on the inside. So this would be 2 times x, which would be 2x, and 2 times 6, which is 12. So it becomes 2x plus 12. I don't have any like terms to combine, so I'm done. Next one, I multiply -3 times 4, which would give me -12. Then I do the same thing here, -3 times 8x. Well, negative times a positive is negative, so that's -24x. There's no like terms, and so I stop there. Last ones, I gotta combine like terms. Remember, things are only like terms if their variable looks the exact same. So like x squared and x are not like terms because they're not the exact same. X and y are not like terms, but x and x are. So let's see, I have 3x, that's a like term, to positive 10x, make sure you take the sign in front, and positive 42x. So I add those all up. 3x plus 10x would give me 13x. 13x plus 42x would give me 55x. And then -14 doesn't have any friends. He's not the same as the other guys because he does not have an x, so we just bring him down. Last one. I see 2 terms that have a y, and so I'm going to circle those and make sure I take the sign in front. 5y plus 13y would give me 18y. And then 2x is by itself, so I'll just bring it down.